And what are we talking about today? Well, we're going to discuss how to measure, manage, and minimize embodied carbon in home construction. We'll also dive into the upcoming RESNET Standard 1550, which will help construction teams track and report embodied carbon. And finally, we're going to look into which building materials contribute the most, but also how to make smart choices like the ones that are featured in real-world case studies of affordable low-carbon homes that we will feature later in the presentation. Here to walk us through all of that is Chris Magwood, who is the manager of carbon-free buildings at Rocky Mountain Institute and director of HomebuildersCAN. Chris joined RMI's carbon-free buildings team in 2022. He leads efforts on HomebuildersCAN, which is a unique community of practice for homebuilders working to decarbonize, and the development of the RESNET ANSI Standard 1550 for the measurement and reporting of embodied carbon for homes. Now, earlier in his career, he helped to establish Builders for Climate Action, has been leading the development of the BEAM carbon estimator tool for low-rise construction. He ran a design build firm specializing in carbon storing, healthy, energy-efficient new construction and renovations, and he has had a hand in authoring 7 books on sustainable building. Now, this webinar would not be possible without our friends at NV Energy. By now, you probably know all about PowerShift by NV Energy, but just in case you don't, it helps residential and business customers conserve energy and save money on their power bills. PowerShift is a one-stop resource to find energy-efficient products and services. For more information, check it out at nvenergy.com/PowerShift. Now, during the course of today's presentation, you can submit questions for Chris. Simply use the Q&A function near the bottom of the Zoom window. I'm going to review those questions and pose those to Chris after his presentation. Chris, we are happy to have you make your Green Builder Media debut today.
Great, thanks for inviting me, and likewise thanks to everybody who has decided to tune in today. I'm really glad to be presenting about the RESNET 1550 standard. I'm actually going to start with a little bit of a disclaimer on the standard. Everything that I'm presenting to you today is from the draft standard. That draft went out for public comment at the end of last year, and public comment period is closed, and we're now in the process of responding to comments. So just a little heads up that the things I'm showing you, words may change, things may be a little different, but I think, the standard as a whole, as I'm going to present it today, should be pretty accurate. So thanks for joining us, and I'm going to start just by answering a question that still comes up quite a bit, which is, why should we even care about what this embodied carbon thing is all about? And I'm just going to set that framework a little bit, because that's how I got into this work. I was, as noted in the intro, ran a design build firm. I really wanted to find out the carbon footprint of all the products that I was putting in the buildings that I was doing. And so in trying to do that, I learned that it was way bigger than I thought, and that it was, a little bit complex to figure it all out. But for you, some of that context is that over the course of the past bunch of years, I've been involved in studying about 1,000 homes and measuring the embodied carbon of those homes. And what we've found is that when you sort of add up all the products, we are most typically including here the structure, the enclosure, and all the main finishes in the building, but not things like mechanical, electrical, and plumbing, and no yard work or sort of work outside the boundary of the house. But what we found as an average over all of those 1,000 homes is that there's about 45 pounds of carbon dioxide equivalent, which is sort of the technical term for all greenhouse gases put into the common denominator of CO2, about 45 pounds of CO2e per square foot of construction. That number may or may not mean anything to you. If we add in the sort of things that we didn't count there, but that we've been starting to estimate, such as MEP and paint and some other product categories, there's about another 18 pounds per square foot. So, a typical house is going to be somewhere in the range of 63 pounds of carbon dioxide per square foot. Again, it's just a number to try to put that in context. If we multiply that across all of the low-rise new construction that gets built in a year in the US, we come up with about 53 million metric tons of emissions from all of the products that go into making new homes in this country. To give that some context, that 53 million metric tons from just the home building sector in just the United States is equivalent to the carbon footprint of the entire economies of some other countries like Austria, Greece, Hungary, Norway. So, entire economies where everything they do, every car they drive, every business that gets run, every emission that happens in those countries is about the same size as the emissions from building new homes in the United States. So all of that to say, this is not a small problem, and it's something that if we are going to try to, regulate the climate and have it not spiral out of control, we're really going to have to tackle this part of home building decarbonization. And of course, that 53 million metric tons is if we keep building houses at the speed that we have been over the last few years. But as we all know, the sort of the demand for and the need for more housing exists. So, if we double that, the emissions are going to double. If we triple it, the emissions are going to triple. So, if we do start catching up to the sort of latent demand in the housing market, the emissions profile could be even worse than we think. So at RMI, we study a lot about S-curves and think about, the way things get adopted, where it can take quite a long time for an idea to catch on. But as it does, adoption and implementation of that idea tend to, rise quickly and then plateau when it becomes more normal. And I would say that, if I were to plot the S-curve of embodied carbon right now, I would put us, sort of just on the start of that steep upward slope, right around the place where we start getting, advanced tools and calculation standards. And it is a calculation standard that I'm here to talk to you about today. So the RESNET 1550 standard, I think, is going to fill this really important gap where we have more demand to want to do this kind of measurement now. We have the data to do the measurement, but now we need a standard to be able to do it. So everybody's confident that we're getting, comparable answers and we're all kind of doing it the same way. One of the reasons that we really need a standard, especially for embodied carbon, is that there are a lot of variables for embodied carbon. You can draw a boundary around the measurement of embodied carbon in a lot of ways. You can look at the different life cycle stages. So, are you including from the time a raw material comes out of the ground to the very end of its life? Are you just counting taking the raw material out of the ground or turning it into a product or getting that product to a job site? Each of those is a different sort of boundary box. The project boundary, like I mentioned, you can include different sets of products. You can stay within the walls of the house. You could look at the entire property. So there's lots of different ways that you could frame a study. And so one of the reasons we need a standard is because we need to pick a box and make sure that everybo's comfortable that, okay, this is the box we're talking about. And so when I tell you my answer for everything that fits in that box, your answer is going into the same box. So we need that comparability, because you can look at a lot of different life cycle assessments of homes now, and you will see some very different answers. And part of the reason you see those different answers is it depends, what the boundaries were put around that particular study. And so, we need a standard. Why a RESNET standard? I was really interested in working with the RESNET organization because, the HERS rating system touches a lot of homes in the United States. They're at about 400,000 new homes a year are rated through the HERS rating system. So their infrastructure of professionals are already out there, and they're touching a lot of new homes. In recent years, RESNET has added their HERS H2O, their water standard. They also added the HERS carbon index so that you can use the energy rating from the HERS index to look at the operational carbon of a new building. And so it seemed to make sense that if you could look at the operational carbon through the HERS carbon index, that it would be great to put the embodied carbon right alongside that. And then you're getting more of a whole life carbon footprint of a building by looking at the results from the HERS carbon index and then from this new embodied carbon standard. And in doing that, we're able to leverage a lot of the existing modeling work that those HERS raters are already doing. So, in creating the HERS model for a building to look at its energy efficiency, you've already created most of what you need to be able to do the embodied carbon model. So instead of having, two separate sets of consultants, having to, input all the same information twice, using this standard, a HERS rater is going to be able to sort of port most of the work that they've done and have it, contribute to getting an embodied carbon model done pretty quickly and easily. And so I think it is the ability to put the operational and the embodied carbon of a home together that really makes situating this standard at RESNET make a lot of sense. This is a graph that we did up based on our own look at embodied carbon at RMI, and then the annual report that RESNET does about the sort of, the average HERS ratings and their emissions using the HERS carbon index. And basically what this graph is telling us is that, this big red bar is, the sort of typical embodied carbon, 44 tons for a new American home. And what we wanted to show is that, if we look at all the HERS, the homes that got a HERS score of 55 in the United States, the operating emissions of that building takes a little over 5 years to equal that upfront embodied carbon. And as you can see, the better the HERS score, and also the more a building becomes, the more buildings become electrified, the bigger this red bar kind of stands out as a leading part of as the decarbonization problem. So you can see when we get into quite low HERS scores of 25 or 15, we start getting into 15 to 30 years before the operational emissions have added up to the amount that this upfront embodied carbon was. And so, we can do lots of work to reduce on the operational side, but then we really do need to pay attention to this piece. So I'm going to show you some snippets from the standard just to give you an overview of how it works. And we'll start with the purpose and scope. And so you'll see, I'm not going to read you all of these words, but the purpose is really to focus on homes and to create consistent system boundaries and to use the data that comes from a HERS rating. And for scope, we're really focused on residential buildings, so in the sort of low-rise residential sphere. And importantly, the standard, unlike the HERS system, we're not setting any benchmark. There is no baseline building here. We're not saying this is a good embodied carbon score or a bad embodied carbon score. So we're not establishing any benchmarks or levels of performance. We're just saying, here's how to calculate this, in part because this hasn't been done enough to know what a good benchmark score is. And finally, the standard has to fit within all the other safety, health, and environmental requirements that you would follow to make a building. So in terms of the life cycle stages that this standard draws as its boundary, we are sticking to what's called an A1 to A3 assessment. Those stages are the sort of the making of products. So everything from harvesting raw materials, getting those materials to factories, and turning those raw materials into products ready to go into a building. Sometimes called a cradle to gate scenario. That's where we've put our focus. We're sort of aware, obviously, of the rest of these stages in the life cycle of a product, but for sort of two main reasons, we're not including them in this standard, at least not in the first version of this standard. One is that most of the emissions do occur in that upfront stage, in that A1 to A3 phase. And also, as we explored what data were we going to use if we did include these other stages, the data just wasn't very robust or convincing to sort of feel like we were making useful, or would be able to make sort of useful assumptions and provide useful data to home builders. So we are focused on the A1 to A3 phase. And the embodied carbon math that's kind of gets used in the standard, it's pretty straightforward. You have to be able to understand, how much of a particular material or product you have in the building. And this standard focuses on using area-based takeoffs. So not BIM models or, bill of materials type modeling, but instead saying, well, I have this much square footage of wall and this much of roof and this much of floor and this much of window, and using those area-based models to do takeoffs. And that's because those area-based models are what HERS raters are working from as well. So once they've, assessed a building for all of those important dimensions, they now have all of that dimension information to be able to use for the embodied carbon model. So we've got, how much material, and then multiplied by an emissions factor for that particular material or product. And that comes from environmental product declarations, which I'll get into in another slide. But basically, for every product that the standard says you need to count, you have to know how much of it you have, what the emissions factor is, and then you'll get a total for the product emissions, and then you'll add those up for all the products that are in the building. So in the standard, there's a very thorough table that provides all of that takeoff guidance for how to convert areas into quantities of products. And it also has a sort of data hierarchy, what kinds of EPDs are you're able to use. What do you do if there isn't an EPD for your specific product? All of that is sort of laid out in the standard as well. So because we are sort of basing the standard on the use of EPDs, these environmental product declarations, it's important to know a little bit about them. The reason that they sort of underpin not just this standard, but a lot of embodied carbon standards, is because there is an international standard for how that gets done, how an environmental product declaration is both calculated and then reported. Don't need to sort of do the deep dive into that, but just so you know, it's sort of all of these figures are coming from these reports that the manufacturer undertakes the report, but they're always third-party verified before we can use them in the standard. And the one piece of information that's key from an EPD for this standard is the global warming potential. So what you get from an EPD is for any certain quantity of material. In this case, this is for 1 cubic meter of whatever this anonymous material is. And this is, how many the emissions associated with making that 1 cubic meter. So if you think of our embodied carbon math, if you had 10 cubic meters of this particular material in your building, you would have 10 times 450 kilograms, 4,500 kilograms of emissions associated with that material. So that's kind of what's going to be under the hood of the standard. We had to go through and decide what building products we were going to include in the building. So, what things are in and what things are out. Obviously, there's a balance to be had between the things that a builder has a choice on, things that there's enough data for, things that make enough difference in the embodied carbon to bother counting. So if you take a look at the standard, you'll see, there's a pretty extensive table of all the things that are in, and there's also a table of all the things that are very specifically excluded. And I'll sort of highlight those because in some ways there's the list of exclusions is smaller than the list of inclusions, but we're not including anything about the work of the site or driveways or any landscaping. Balconies, porches, and decks that aren't part of the structure of the home are not included. Anything that's not permanent, so things like formwork, so materials that you use but then take away, the appliances inside the building, cabinetry, millwork, gutters, soffit fascia, fasteners, connectors, controls, valves, and light fixtures, all for various reasons of not enough data or not important enough, are not going to be included. And the standard sets up two different types of assessment that can be done for embodied carbon. Ideally, both of these happen, but to sort of mimic the HERS rating system and the sort of the procedure of a project, there's this projected assessment, and that's what you generate prior to the building being constructed. So you want to know sort of where you're aimed with embodied carbon. You want to be able to, look at the plans and make any adjustments. If you're in a jurisdiction where there's a requirement or an incentive to report your embodied carbon, obviously you can't, you can only report the projected before you build the building. And then ideally, once the building is done, there's a pathway for doing confirmed assessments. So that's where, okay, the building has been built. The HERS rater has been on site a few times and doing their inspections for the energy efficiency side of things. They're also doing inspections or able to do inspections on the embodied carbon so that we know, yes, the things that you said you were going to do over here in the projected assessment, did they actually happen? And if not, we can adjust the model to suit the as-built version of the construction. And that verification, again, we were aligning ourselves very closely with the procedures that a HERS rater would undertake, and so the verification follows the same kind of methodology that a HERS rater would use to do verification work on the energy efficiency side. So basically, while you're on site, looking at the types of products, the brands of products, and comparing that to the original assessment and making any adjustments for changes that were made in the field. And so, by and large, that verification procedure is, just making sure that the building is the size and shape and, has all the dimensions that were assumed in the plans. And then to, make sure that we know which brands of products were used and, collecting the photos or receipts or other documents that it would take to sort of be able to prove that. And software-wise, there isn't any software that can, do a 1550 compliant assessment right now because there is no completed 1550. So there will, obviously be a bit of a lag between the software, between the standard being published and the software being available to do it. But there are representatives from two different software firms on the standards committee, and presumably there will be efforts underway to make software that will kind of do all the work, the hard work of the following the standard for you as a user. And one of the things that has been happening prior to the standard coming out in Massachusetts, there's been this 100 homes study to try to come up with a benchmark embodied carbon for homes in that state. But that kicked off an integration of the software, the Ecotrope software. That's a HERS rating software where, the HERS raters already put lots of the information about the building in. And there's now a prototype connection between Ecotrope and the Beam rating software. So as I was saying earlier, you're able to take as much information that you put into Ecotrope that's valuable to the embodied carbon model and just port it over to Beam, so you're not having to double enter. And that, I'm sure, will happen more and more once the standard is available. So that's the sort of the outline of the standard, and I'm going to sort of show you, with a standard like that, or even before the standard, what we can do about embodied carbon in new construction. And this is our kind of stock slide of the embodied carbon reduction hierarchy, the kind of like, impactful steps that you can take to reduce embodied carbon in buildings. You'll notice I've struck the last two out here, not because they're not important, but because, the RESNET 1550 standard isn't looking at transporting materials to site, isn't looking at end of life, isn't looking at circular construction. So really, ResNet's going to give you some real clarity on these first three parts of the hierarchy. So the first one is using less stuff. That can come in sort of three basic flavors. One being reusing things, whether that thing be a whole building. So instead of tearing down an old building to build a new one, can you keep the old building? Can you keep a fair bit of the old building? And the reason for that, from an embodied carbon point of view, is the emissions it took to make those materials originally, back whenever that building was made, they're already in the atmosphere. So if you can not have to make a whole suite of materials to replace them, the embodied carbon of the project is lower. Same goes for if you're just reusing some of the materials or getting used materials from another site to put into a new building. Anything where the emissions have already happened in the past don't sort of count as new embodied carbon, because they're not responsible for any emissions today. Right sizing and dematerializing. This is sort of looking at your building. We'll check out a couple examples of that in the next couple of slides. But this is the stuff where people do think about embodied carbon. I think the notion is, oh, I got to start switching products. But really, thinking about embodied carbon starts here with, what do I actually need to use? How little of it can I use? And am I using the appropriate amounts of them? So I'm going to show you a couple of examples. Here's the little plus sign looking things. That's just like a simple foundation for a building. And so if that building is 1,120 square feet, and I use a 10-inch wide concrete wall for the foundation of that building, I need 34 and a bit yards of concrete for that foundation. But if I can make that same foundation with the wall only being 8 inches wide, I'm down to 27.7 yards. So I haven't changed the kind of concrete I'm using or whether or not I'm using concrete. I'm just, using less if my code allows that and if the structure doesn't require it. Lots of times we tend to just use more material just, to be on the safe side. So if you can kind of do some value engineering, you might find that you don't need as much of these materials as you thought. And so, in this case, it's a 20% savings. And when you use less in embodied carbon terms, the embodied carbon reduction tracks, exactly. So if you use 20% less concrete, your emissions will be 20% less. So that's sort of one part of using less stuff. The other part of using less stuff is, here's this same foundation. We're going to leave it being 10 inches, the concrete being 10 inches thick, because we need to. But if we just, squeeze the size of the building down slightly, this is, I think, shaving just under 10% off the size of the building. Again, we get a 10% reduction in the embodied carbon for having used 10% less material. Now, if we combine both of those measures, a little bit thinner, a little bit smaller, we've added those savings together, and now we're seeing a 30% reduction from those two measures. Now, the next kind of step in the hierarchy is what I call using better versions of the same stuff. So this is where we're not getting into changing out product type A for product type B. So in this example, we're still using concrete. We've decided how much we're going to use and how thick it's going to be, and all of those things are set. Now we're kind of into the procurement decisions, the what type of concrete am I going to get, which supplier am I going to use to supply me, and just to sort of give you a sense of what's on the table when it comes to that. This same foundation, there's 7,390 kilograms of emissions if we use just like a very standard mix. This is based on the NRMCA's national average for concrete. The NRMCA's best low carbon mix, so same strength category, lots of the same characteristics, but different ingredients to get you to that same strength. The emissions there would be down to 4,725 kilograms. So a 36% savings from looking at, what kind of concrete am I going to get, who am I going to get it from, and what goes into the mix. So there's a substantial amount of savings there. Now, if you think back to our previous example, if we can save 30% by making it thinner and smaller, and then this 36% from using a better mix, we've almost half the carbon footprint of this foundation. So these things are not, exclusive ways to reduce embodied carbon. Ideally, they're sort of additive, and you can put them together. So another example of using better versions of the same stuff, we can look at a category like drywall. We use lots of it in homes. Like a fairly typical home's got around 4,000 square feet of half-inch drywall. And what I'm showing you here is the global warming potential of 5 different brands. So if you went to a retailer and picked up these sheets of drywall, everything about them would be the same. They have very similar performance characteristics, very similar price. All of that kind of stuff is really similar. But if you look at the difference between the brand with the highest embodied carbon and the brand with the lowest embodied carbon, there's a 65% difference in that spread. And so this is where you're still going to use drywall in this building, but you think, oh, I'm going to choose brand A instead of brand B because look, their embodied carbon is 60% lower. So that's another look at how we can use better versions of the same stuff to reduce embodied carbon. And then there's the piece in the hierarchy that I call using better stuff. And this is now thinking about different product types. So I'm going to use as the example here exterior cladding for a home. So say we've got a home that needs 2,000 square feet of exterior cladding being covered. Here's the average GWP for 12 different cladding types, and I'm gonna as a caveat here, say you saw on the drywall example how big the spread can be in any one category. There is a spread in all of these categories. So what I'm showing you is the average for brick and the average for acrylic stucco, etc. But the worst performing brick and the best performing brick, there's a pretty big spread there. And so it may be that the best performing brick is as good as natural stone, or the worst performing steel panel is, anyway, you get the idea. There's a range here. But if we take their averages, again, you can sort of see from brick at the top end of the spectrum to natural wood at the bottom end, there's almost 100% difference between the embodied carbon of those options. Now, I know there's all kinds of reasons you would use brick instead of wood, or wood instead of fiber cement. Embodied carbon is not the sole reason that you would be making these choices, but it is a good thing to be looking at. And if the needs for your building, the aesthetics of the building, the cost that you're trying to aim for the building happens to align with a better embodied carbon choice, there's a good reason to be doing that. And you can see the spread here is wide enough that it is worth considering. Now, I added this little section just for this presentation, which I'm sort of tongue-in-cheek calling use your judgment instead of use less stuff for different stuff. And that's because the standard, the 1550 standard, is going to include mechanical, electrical, and plumbing equipment as part of the assessment. This is really new. Most, especially residential embodied carbon assessments, have not included this in the past, but the committee did a lot of work to find really good default values that we could use for this. So, in the range of MEP equipment that we're including, most of the products, there's not very good representation of individual products with their own individual EPDs. So in a lot of cases for the MEP section, you're going to be using defaults, and everybody's going to be using essentially the same numbers. But the things that vary are the square footage. So things like electrical wiring, we're just using industry standards for a house of X thousand square feet. you tend to use X amount of electrical wire cable and switches and boxes, et cetera. So those are just, standard baked in calculations. But, there are differences between, the embodied carbon of a domestic tank hot water heater and a tankless and, heat pump hot water heater, and et cetera, all the way down the list. You'll see with the mechanical, you can put in, a variety of different types of equipment, and you will get some standard embodied carbon information back for all of those. So I'm going to now show you a couple case studies. So with the HomebuildersCAN group at RMI, one of the things we do is build up a case study library. So this is one of, I think, there's about 14 case studies in the library right now. So you can go to the website and download these. I'm just going to show you a couple of them, and the reason that I want to show them to you is just, to show you that thinking about embodied carbon isn't that hard. There are lots of builders doing it already in advance of the standard, and that some of the changes and some of the the design changes, the product changes, all of that stuff. There's always an assumption that these kinds of things are going to be more expensive. And so most of our case studies feature buildings where the builder kind of did all of this work and was like, oh, that actually didn't really cost more, or sometimes it even cost less. So that's very much what this particular case study is looking. You can see that Cody Fisher from Footprint Development, who sort of led this project, said a third of the embodied carbon reduction that they found here was cost neutral. So, basically looking for the low-hanging fruit. You can see that this building, it's a small multifamily building. It really did do a great job on embodied carbon. So, we found that about 200 kilograms of emissions per square meter is a pretty average home. And you can see that this building got down to 40. So, that's a really significant reduction. They did things like target low GWP concrete. They use cellulose wall and acoustic insulation, et cetera. You can you can check out the case study and look at all of the ways that they did that. But I want to show you one multifamily building. I think a lot of people think that some of these embodied carbon interventions kind of only work on really small, really custom homes. So this is an example of a multifamily building. Also want to point out that we try to, in our case studies, feature buildings that have kind of addressed the operational side of their emissions as well. So in this case, this building has a FIAS core certification, and it's all electric. So its operating emissions are already super low. And so kind of the next frontier for a builder like that is to bring the embodied carbon down. Similarly, on the single family side, actually this is not a single family, it's a duplex. But same kind of approach, what's the low-hanging fruit when it comes to embodied carbon? You'll see that there are actually some similarities between some of the choices in this project here and the previous one. But cellulose insulation, wood fiber board, denim bat insulation, some sustainably harvested wood. In this case, it was a panelized construction, so sort of making it easier to put some of those products that lots of builders aren't necessarily familiar with, being able to put them together. But again, a building that is passive house levels of energy performance, all electric, and again, getting sort of about a 75% reduction from a typical embodied carbon. So just wanting to show you a couple examples where it's like, yep, we can do this today. If I were to show you, buildings where they've, made their energy performance 75% better, that would be kind of jaw dropping. But right now, embodied carbon is so new, and the understanding of it and where we are in sort of our baseline buildings means that there is that kind of low-hanging fruit. Right now, if you think about those of us who have worked on energy efficient buildings for a long time, things like making the building more airtight, going from single to double pane windows, those sorts of steps, 25, 30 years ago made huge gains in energy efficiency. And we're kind of at that point with embodied carbon where there just is a lot of low-hanging fruit. If you can use something like the 1550 standard to find it, it's not actually that hard to implement it in a way that makes a really big difference. So I'm going to return to my S-curve here. So we now do have this standard, or we will have the standard soon. I would expect it to be published, sometime around the middle of this calendar year. So coming soon. So that gives us the ability to calculate, but we still have a long way to go before our buildings are kind of at the zero or very near zero emissions that they need to be for the climate to stay within reasonable balance. And so, we need things like mandatory reporting, mandatory limits, actually reducing those mandatory limits, and then getting into to carbon storage before we're really going to be able to address, that huge pool of emissions that new homes in the US represent, as I showed you at the start. If you're looking for some resources to go a little deeper, the Hidden Climate Impact of Residential Construction is a report that my colleagues and I did at RMI that kind of summarizes all of the residential embodied carbon studies that we could find. And then some of those individual studies you can see here as well. And the BEAM tool is a free tool. Like I said, it doesn't calculate according to the 1550 standard right now. The methodologies are very similar, but the range of products that is included and some of the the nuances aren't exactly in line with 1550, but will be soon. The BEAM tool is what was used for most of the studies you can see on the screen here. And so with that, I will wrap up the formal part of the presentation and glad to get into some Q&A.
All right, thank you, sir. Just gathering up some of the questions that we've got from our audience, and wanted to go ahead and pose a couple of those to you now, Chris. Mm-hmm. The first question that came in was, is the standard going to align with material standards that are published by ASTM and or UL, or United Laboratories?
Well, yes and no. I mean, those two organizations don't look at embodied carbon, but the most typical scenario is, what the standard does is give you an embodied carbon, a GWP factor for products that have already met those standards and can be used in buildings. So, for example, like if I just pick up a stick from outside, I could say, well, this stick weighs this much, and so this must be the embodied carbon of it if I'm looking at this factor, but I can't legally use that stick to hold up my house. But if I go to, the lumber yard and get, a grade stamp piece of lumber, I'd use the same embodied carbon number to assess the grade stamp lumber as the stick. And so, those ASTM and UL standards, those are there to sort of ensure that products do what they're supposed to do performance-wise. And then the standard says, and here's the embodied carbon number for a product that meets those requirements. So they don't quite overlap, but you would, in the list of products that are included in the 1550 standard, they're all products that we use in buildings now and that have met all of the performance requirements to go into a building.
Okay. So Frank had a question. You kind of gave us all a little bit of a teaser when you were talking about the different drywall options. He's wanting to know, can you name some brand names here for better carbon options?
I'm not going to do that here, but I would say like that all of those numbers come from the BEAM tool, and the BEAM tool does name names. I just don't like to, pick on anybody or, elevate somebody because, there's never a silver bullet, right? You could decide, nope, I really like high GWP drywall brand, and I'm going to stick with that because you know, I'm dropping my embodied carbon emissions by using a lower carbon concrete or different windows or a different insulation. So, like, until you're at the point of, we've kind of designed the building and we're picking products. I don't like to name names if I don't have to.
And that's fine. That's kind of what I figured anyway. But one of the things we do here is we always try and get to all the questions we can. So I appreciate it, and I understand the situation you're in there. So let's stick with the drywall for just a second, though, if we can, Chris. So Chloe wants to know what accounts for the embodied carbon difference with the different drywall types and other products within the same kind of product category. She's wanting to know, does it have anything to do with maybe how clean the power grid is in the location where it's produced?
Yep, that's a big part of it. So yeah, the whatever the manufacturing process is, so that can start with where did the raw materials come from? Is this a deep mine or a surface mine? Is it, there sometimes there's differences in that the sourcing of the raw material can have a lower carbon footprint. Then we add the transportation of the raw material to a factory. So if, you're getting raw materials from the Northwest, but you're manufacturing them in Florida, that's going to put it up. And then, yeah, to her point, the types of fuels being used in the manufacturing, yeah, cleaner grids, good heat recovery, all of those things. Like the more efficient the factory, the lower the embodied carbon should be. So that's kind of what's showing up in most of those products.
Okay. Ashley wanted to know, can this standard be used when renovating existing buildings or the renovation of existing buildings?
Yep, yep. So there's a renovation piece embedded in the standard too, which it's pretty simple. It says don't count embodied carbon for anything that you're leaving in place. So you would just count embodied carbon for new materials that you're bringing into the building. So like I said before, we kind of assume emissions from existing materials, like they're in the atmosphere now, we can't do anything about them. So, the person doing the renovation sort of doesn't have to own that. But so for renovations, it's really just what are you changing out, and you would do it's the same process, but usually just on a smaller range of products. Like maybe you're just putting in a bathtub, you would just look at the embodied carbon of the bathtub. If it's a whole bathroom retrofit, you'd look at the flooring and the drywall, and all the things that you're going to add.
All right. We got more great questions, Chris. We're going to keep rolling here.
Yeah.
So someone wanted to know, what happens when a building's design doesn't match what is actually built from a regulatory context?
Well, I mean, I guess like building permits and like the structural integrity and the energy efficiency of the building, like that's not part of our standard. Um, but if you're doing a verified, if you're verifying the assessment, the rater on site would be like, oh, that window's twice as big as it said it was going to be in the plans. So I have to go back now to my embodied carbon assessment and, you know, change the window from being, 2 feet by 3 feet to 6 feet by 8 feet, and I'm going to get a different embodied carbon number. Or, whatever changes are noted on site, you make sure that the final verified embodied carbon assessment matches what was actually built. So that could be, oh, they said here that it was that to our drywall conversation, this was supposed to be drywall brand A. I get to site, it's actually drywall brand B. We're going to have to go change that in the assessment.
Okay. Another really interesting question, at least from my perspective, from Mary, has durability been factored in? And if not, is that something that will be considered in the future?
I mean, it has not been included uh, because it it's hard to include, I guess would be the main thing. So again, this standard doesn't say product A is more durable than product B. That's going to be the call of whoever's, designing the building. Where that does impact embodied carbon is, if you put in a product that lasts, 10 years and then you have to replace it, you're gonna be creating more embodied carbon 10 years from now. If you put in a product that lasted 20 years from the get-go, like its embodied carbon happened once, but doesn't have to happen again until 20 years. In general, the length of time that the things that stay in the building for this standard, like everything is sort of in the 15 to 20 year kind of lifespan range. So that's why we're not counting a lot of things, like appliances and stuff that tend to be changed out more often. But it's also really hard to, we either have to go with a lot of assumptions, like this product is going to last 10 years, but what if it lasts 30? Or what if the product that was supposed to last 30 years, the house sells and the person, that has the 30-year product rips it out because they would like something else anyway? Like that, what happens, in the future of the building, it does have climate implications for sure, but ones that are very hard for us to predict and for like the building's designer and builder to kind of own at day one. But we will be looking at how to think about that more holistically down the road. But it was, the sort of network of assumptions and trying to figure out, how to navigate that. We just didn't take that on in this round.
Well, I can see that certainly being a challenge for something like this, because I think a lot of our audience may or may not know, I don't know. Ratings are an assessment at that specific moment in time. And things can change on the property that would make that property be rated very differently, were the rating to be done again in the future, that would say, well, this doesn't match the rating from 4 or 5 or 10 years ago. And that's just the inherent nature of ratings, is it's looking at that snapshot in time. So I can see where, a homeowner, a new homeowner, a different homeowner makes changes. Now all of a sudden that home isn't going to be the same. It isn't the same.
And I think, somebody, if you are concerned about durability, as a designer, you sort of know what the anticipated lifespan of some of these products are. You can take a look and go, well, yep, this product has a higher embodied carbon. I'm going to choose it because I can see that replacing it with this other one that's going to need 3 lifetime replacements in the same time as the high embodied carbon one isn't going to work out well, so that's fine. Or you can look and go, oh, you could replace this material 10 times before it has the embodied carbon of this one that's really high. It doesn't matter that it's not as durable. Those kinds of conclusions, you'll be able to extrapolate that from doing an assessment, but the assessment isn't going to tell you those things.
Now let's stick with the durability topic for just a second, Chris, because Jacob wants to ask, isn't durability kind of calculated into the EPD?
No, not really. So the EPD is like the part of the EPD we're reading is like what were the emissions associated with getting this product ready to go out to a building. So no, like I could create a lot of emissions making something that melts 3 days after I ship it out from the factory, or I could create hardly any emissions and make something that's going to last 1,000 years. It like the amount of emissions that it took to make it is never directly linked to how long it might last. So they're two kind of separate things. In an EPD, you will see what the manufacturer's, anticipated lifespan for that product is. And that is something that you could use as your own guide to, like, am I making a good long durable choice here or not? But anybody who's been in the building world knows that the manufacturer's recommended lifespan may be much longer or much shorter than than, what happens in the real world. So I think, people in the building design world are savvy enough to be able to understand that piece. We're not positing that embodied carbon is the only reason you would make any building choice. It's sort of one of many stacked reasons. We're all aiming for healthy, energy efficient, code compliant. There's a whole list of criteria, and the 1550 standard will let you put embodied carbon as one of those criteria. And it's not likely going to be the main reason you make choices, but it could be a good supplementary reason. Oh, I could use X or Y. They all seem pretty similar, there's not much difference between them. Oh, let's look at the embodied carbon. Oh, like there's a clear choice, from that perspective. But I wouldn't want to see people using an embodied carbon standard to design a building. That's not what it's for. It's to inform your sort of design and procurement choices towards, being better for the climate.
Okay. So a question came in from Ted. Does the standard recognize the difference in embodied carbon between organic materials versus man-made materials?
So, well, yes and no. So if a product has is made from sort of biomass, from biogenic carbon, then that is something that's tracked in the standard. So you sort of see if it's a product that's made from plant material, you'll see the emissions it took to make that product, but also the amount of carbon that's physically stored in it. So that in that way, it's you see those two things. But if if you have like a stone, or you have concrete, which is sort of like synthetic stone, you can find the product rating for stone, you can find the product rating for concrete, but it's, there's the GWP doesn't matter whether it's man-made or naturally occurring.
Okay. So a question came in from Frank. Is the MEP info also now available in the generic BEAM tool and the HOT 2000 MCEE2 tool?
No. I'm assuming it's going to show up in those tools right after the standard comes out, but I think, everybody's waiting for the standard to come out to know that they're picking the right numbers. So I would assume that there's going to be some alignment with those tools and the standard pretty quickly.
Okay. Okay, so another question came in from Colleen. Up to what size multifamily project is this going to cover? Your case study talked about a 4-story home, but is this thing meant for mid-rise or high-rise as well?
It certainly could be used that way. I think the line will sort of come depending a bit on construction types and like who's involved in the design and the energy analysis side. So, the kinds of typologies, this is really aimed at the typologies that HERS raters already rate, which is, pretty typically like 5 stories and under, often wood frame or CMU, some concrete buildings, but that building typology, if you have a HERS rater doing it, it makes a lot of sense to use 1550 because they're going to be able to use the same information. If you are designing larger buildings, concrete buildings, steel buildings, you're making BIM models, there are standards and softwares, already out there for that kind of construction and that kind of model building. So I would say, you would want to use the one that's kind of appropriate for what you're doing, gives you the kind of answers you want. If you're HERS rating your buildings, it's probably good to use 1550. If you're not, and you're doing larger buildings, you probably want to use something that works with your software.
So I really like this question that Brenda sent in, because this is, I think, something that often gets either overlooked or underappreciated in our industry. She wants to know, are financial institutions and appraisers recognizing embodied carbon and energy efficiency standards in underwriting and valuation for any type of residential property, new or existing?
The answer to that is not yet, but in talking, in my job, I talk to a lot of people in the financial world, and all of them basically wanted some sort of standard like this so that they could start looking at that. If people are just going to sort of like randomly come up with a, life cycle assessment number for a building and try to use that, it's hard for does anybody, in the regulatory world, whether that's code officials or, investors or financial people, like, what does this number mean? Am I looking at a good number or a bad number? Who did it? Like, what were the assumptions? But what I'm hoping is that now with when 1550 comes out, that yes, like we will be able to start making some of those inroads because, they will be able to say, we'll give you extra whatever if you meet this threshold. And we know that's a good threshold because, we've gotten lots of results out of 1550 standard and we know what's average and good and bad and able to start making some of those judgment calls. So, that's for me and our team at RMI, that's a big reason for doing the standard is you need something like that to be able to underpin the kinds of decisions that we want those kind of financial people to be able to make.
So we've got a couple other questions, and then we'll wrap up here. We hit on this a little bit earlier, but I think there's a little bit more to this question. So it's a two-parter. Is the geographical location important to embodied carbon? But also, part of it is not just what we talked about earlier about, oh, maybe because it's on a clean power grid. The question is going a little bit more towards the accessibility to items or maybe some of the climate risks that are included.
Yeah, so I mean, yeah, geography makes a big difference, like you said, like if where the factory is and what its power grid looks like and how far it has to move raw materials matters for sure. On the flip side, again, this is a tool you might look at, be looking at say the beam tool and go, oh, I really would love to get drywall product A. There's not a single retailer within, 500 miles of me that carries that. Like you're just not going to be able to. And, it's unlikely to be the right decision to be like, well, I'm going to put two skids on a truck and, drive it, 1,500 miles to get to my site. By the time you've done that, there's a good chance you've created more emissions than you've saved by going with product A. So I think, geography right now will be a limitation. I know, when I showed sort of average concrete and low embodied carbon concrete, not every small rural batching plant will make, low embodied carbon concrete right now because there's not enough demand. They don't sort of silo the ingredients that need to go in it. So, there will definitely be limitations to what products you can get based on your geography.
So I'm going to kind of reword this question a little bit because we're talking about a standard that isn't finished yet. And I think you said the hope is that they were going to try and publish something in the middle of the year. Is that correct?
Seems like we're kind of on track to do that, yeah.
Okay. So let me reword this question slightly. Who is going to employ HERS embodied carbon raters? And is this geared towards like construction companies that are going to voluntarily care about this, or is this more focused at cities or something else?
Am I allowed to say all of the above? I think, that the standard committee it's a really interesting mix of some really small, really progressive home builders who, been at the forefront of energy efficiency and passive house and stuff for a long time. And they're kind of seeing this as, an important next frontier. We also have representatives from a lot of the leading builders of America group, which are the sort of 20 largest production home builders in the country. because they know this stuff is important too. They want to understand it. They want to be at the table. They're going to be, training their own staff and or their HERS raters to look at it. Um, you know, some people are going to do it voluntarily. Cities and states are going to start to, once there is a standard, be able to set a threshold and, you know, likely with voluntary incentive programs first, but eventually, it will become a code regulated, aspect of a building. Already, California has its Cal Green code, which is an embodied carbon code. Oregon is about to move into doing an incentive program, but ahead of doing codes. Where I am in Canada, the city of Vancouver is already doing embodied carbon programs like that. So it's coming. I think the people who are going to use 1550 first are the ones who want to be ahead of that curve. Like, I'd rather know now and understand this and be able to do this and know where I'm at, know where that low hanging fruit is, know how much it's going to cost, all of those sorts of things before it's code. But I think, the codes are definitely, coming in the next, 5 years or so.
And let's go back to the first part of their question. Does the committee, I'm not going to say you, Chris, you get to answer this, but like, does the committee kind of envision that existing HERS raters are also going to then pick up embodied carbon ratings, or
Yes.
do they think that there would be a whole separate group of individuals focusing on the standard 1550?
Yeah, I think our assumption, and we have quite a few, both like HERS raters and HERS rating companies at the table. They see this as I'm already doing 80% of what I need to do to make one of these embodied carbon models. Some of the folks working on that 100 home study in Massachusetts are finding it's an hour to add embodied carbon to the work I already do, because we tried to align, the workflow of the HERS rater and say, like, what are you modeling? Like, what numbers do you already have? How do we translate those into embodied carbon? We've kind of made it as easy as possible for a HERS rater to do it. I don't think, somebody might want to go into an embodied carbon only HERS rating practice, but I doubt they're going to do all that well financially, until the market grows. But for somebody who's already doing HERS ratings it's a big additional piece that you can offer your clients for a relatively small investment in time to be able to do it. So I'm assuming, both the builders and the HERS raters, sometimes it'll be the builder asking the HERS rater to do it. Sometimes it'll be the HERS rater saying, hey, I just got certified in 1550. Like, I could be doing this for you now. But I think, and it doesn't just have to be HERS raters, folks who do FIAS or Passive House could be doing this. Basically, anybody who's making an energy model of a building, you've done the majority of the work to be able to do an embodied carbon model too.
Gotcha. Well, thank you, Chris. I definitely appreciate the presentation. I know our audience was very intrigued and inquisitive about it. So thank you very much for taking the time to walk through this with us.
Yeah, thanks to you and the team at Green Builder and everybody who took an hour and a bit out of their day to listen.
Yeah, and also thank you to PowerShift by NV Energy for their generous sponsorship. Now, in case you haven't registered yet, and I know that you will, the Green Builder Media Sustainability Symposium is coming soon to a computer screen near you. It's going to take place on April 30th and May 1st, and it's going to go from 12 to 3 p.m. Eastern each day. Now, this wonderful event that I get the honor to MC is completely free, so don't miss it. Just go to greenbuildermedia.com to register now. And between now and then, we'll have another Housing 2.0 workshop on April the 3rd with Sam Rashkin, and we'll be talking about the Water Energy Nexus with Darren Waschek on April 9th. So stay tuned to your inboxes for registration info on those two webinars. Thanks again for joining us today. Congratulations once again to all the working moms out there, and I hope to see all of you again soon. Until next time, stay safe, stay healthy, and take care, everyone. So long.
Okay.